chlorine, so it has 17 electrons. Okay, so they have the same number of electrons, so the answer is C. This pair has a difference of 2 electrons. So you're looking for something, again, left to right, okay? Difference of 2 electrons is too many to be looking up and down. There's too much of a difference of electrons if you have 2 elements that are up and, that differ vertically. So the only other real option that we looked at that was also left or right would be, I believe, this first one, nitrogen and helium, and neon. They're both in the same period, okay? So if nitrogen has a charge, instead of 7 electrons, it has 8. So N equals 8 electrons. And how many electrons does neon have? Well, it has 10. 10 electrons. Okay, that's a difference of 2 between 8 and 10. So the answer would be A. What about the second question? Potassium is a mineral necessary to biological processes and found in every cell. Is it an ion or an isotope? Okay, so this is something that says there's an imbalance of electrons. This positive sign, okay? That is going to be a isotope. Right? No, sorry. It's an ion. It's getting late, folks. It's an ion. So potassium is element 19, right? So that means 19 protons. Start there. And then it has a plus charge. So it has 1 less. It's missing an electron, so it only has 18 electrons. Okay, so these are not balanced, so it's an ion. And that's how you would explain it, imbalance of electrons. How many electrons are present in Mg2+? How do you know? Again, magnesium, 12, has a mass number of 12. Okay, and then 2+, so you're going to subtract 2 electrons, gives you 10. 10 electrons. How many valence electrons does magnesium have? 2. So 2 valence electrons. So basically it just lost its 2 valence electrons. Okay. Why would it do that? Well, now we know it's because a more electronegative element such as oxygen or fluorine took the electrons from magnesium. Right, complete the following table. Okay, so some more isotope practice. All right, so we'll count up the protons, electrons, and neutrons first. All right, I see that there are 3 protons. I see that there are 3 neutrons. And I see that there are 1, 2, 3 electrons. Okay, so 3 protons, that's going to be lithium. So lithium. Isotope symbol, Li. Okay, to write the isotope name, we would say lithium, and then write its mass number, which is the protons and the neutrons together. Remember everything in the nucleus, so lithium 6. Right? What about this one? We have 3 protons. This time we have 4 neutrons. Okay, still lithium. Still symbol Li. So we're talking about lithium. Oh, there's also 3 electrons. So the electrons and protons are balanced. So 7, lithium 7. Okay, what about this guy? 3 protons, 5 neutrons, and 3 electrons again. So again, lithium, the symbol is Li, and then we have lithium 8 this time. Right. Which of the following has 6 valence electrons? Okay, if you have a periodic table like this where you haven't labeled the main groups, then just remember it's the group number minus 10, right? So instead of 13, it's 3. 14 is 4, and so on and so forth. Okay, and then you can tell the valence electrons. And then you have 1 and 2 here. They're already 1 and 2. So 6 valence electrons, we're talking about something in main group 6. In this case, it's going to be sulfur. Next 4 questions refer to these atoms. Which has the smallest atomic radius? If you look at this image here, here it is. Atomic radius gets smaller as you go to the right because there are more protons. Okay, but they get larger as you go down because there are more electron shells. So we're looking for something anything that's further to the right and up is going to have a smaller atomic radius. So what's going to have the smallest out of these 4? Well, lithium's over here, carbon's over here, nitrogen, oxygen, fluorine. So it's going to be fluorine. It's furthest to the right. Has the smallest value for first ionization energy. The lowest ionization energy goes in the opposite direction of atomic radius. That's the energy to remove an electron, okay? So we want something that doesn't attract electrons, so it has less protons. So we're going that way because there's less protons as you go in this direction. And we want something with lots of electron shells that will keep the electrons far away from the nucleus. So we want something that's down too. So we want something that's over here, or the lowest, or the closest to this direction. In this case, it would be lithium because they're all in the same period. Is found in the halogen family. Fluorine is in the halogen family, and it is a metal. Lithium wasn't an option here, my bad. Magnesium, which should be your answer for 21. 23 is a metal. That would also be magnesium. It's over on the left side. Which diagram shows the relationship between electronegativity and atomic number for the elements of period 3? Just skip that one. It didn't print right. What is the least electronegative element on the periodic table? Right? So if the most electronegative element is up here, fluorine, which is also the smallest, then the least electronegative is going to have to be down here. It's cesium, but if you wrote francium, I would give that to you as well. As long as you know it's there. All right, let's complete this table. Are electrons transferred, shared, or in a sea of electrons? Ionic, they're transferred. In covalent, they're shared. In metallic bonding, it's a sea of electrons that are free to move around like drops of water in the sea. Sea of electrons. Type of elements that make this bond. Ionic bonding is going to be non-metal plus metal. Covalent bonding is non-metal plus non-metal. And metallic bonding is just metal. Properties of substances with this type of bonding. Melting point. So covalent is usually low melting point. That's like sugar, melts at a low temperature. Ionic is high melting point. And so is metallic bonding. Remember, we tried to melt these things and it didn't work in our lab, or at least some of you did. Conductivity. It conducts. Metallic bonding conducts. Covalent bonding does not conduct.